How are you?
Good. So what are we doing today? Before more trig, I imagine.
Yeah. Looks like we're doing trigonomic functions of real numbers.
Oh, thank goodness. The only reason I say that is because for some reason trig courses insist upon making the first chapter the toughest chapter in the book almost.
Yeah.
It's I think an attempt to explain the difference between degrees and radians. It's like that last problem you gave me, where the thing was split up into radians, not degrees. And it's not that tough of a concept if you just teach the conversion factor, pi over 180 or 180 over pi, and just go from there. So, what kind of problem
Alright, so
you got here?
find the exact value at the given real number.
Okay?
So it's got three parts. First one, sine of 2 pi over 3.
Hold on.
Sine 2 pi over 3.
No, tell me, Mike.
So the exact value.
Just a second. For some reason, my drawing function is not working. There it is. Sorry about that. Sine of what? 2 pi over 3?
Yeah.
Okay. Let's go back to this unit circle. And we know that I'm going to show you how to do these my way, because I think it's the best way. In other words, between this information that I'm writing on there, you can figure out the value of any trig function as long as you know the first quadrant values. In other words, what quadrant is this in?
Second.
So which of these do I use to convert it to a first quadrant angle?
The theta minus, or pi minus theta.
Which gives you? Theta is 2 pi over 3.
Pi minus 2 pi over 3. So
Which
3 pi over 3?
Right. So in other words, we're looking at the same thing as this in terms of the absolute value number. What's the sine of pi over 3 equal to?
Don't tell me. Like,
You need to have the first quadrant memorized. Let me show you.
Degrees, right? 60 degrees?
Yeah, it is 60 degrees because the denominator always multiplies with the 60 to equal 180. You draw these two triangles up here, and this will allow you to come up with the first quadrant values of all of them. In other words, you don't even have to memorize those. If you have this memorized, notice that the sine of pi over 3 is 60 degrees. So if we look at the 60, it's root 3 over 2. Is that positive or negative?
Sine is the x-side, so it's positive.
Good. That's all we're going to do.
So that's the exact value, is just that coordinate?
Yeah. In other words, the sine of the exact value is always a ratio. Trig functions, you take trig functions of angles to get ratios. So if I take the sine of 30 degrees, it's equal to 1 over 2.
So then the next one is the cosine of 2 pi over 3. exact value would just be 1/2.
Okay, so first of all, we applied this formula there to convert it to the same as the sine of pi over 3, which is 60 degrees, which is 1/2. But now what's the plus or minus sign on it?
Minus.
See how easy these are to do without memorizing the entire unit circle, which I think is ridiculous to have to
I've memorized the basic. I've memorized just
the first quadrant is all you need to memorize, is that first quadrant. Because every other quadrant we can get by using one of these formulas. Notice that one of these is in degrees, one of them is in radians. Radians, degrees, degrees, radians. Okay? So let me give you one. What's the tan of 210 degrees?
All right. Yeah, well, I know it would be negative root 2 over 2. Just because it's tangent.
Which quadrant?
The third.
Positive in the third.
Oh, yeah, positive.
Okay, and it's the equivalent of what angle? What first quadrant angle?
Root 2 over 2.
In other words,
45 degrees.
No, use that definition right there because we're in the third. So take
10 minus 30 degrees.
So 30 is its equivalent. Now what's the tangent of 30?
No. Is it root 2 over 2?
Look at this triangle right here. What's the tangent of 30?
Tangent, 1 over root 3.
Right?
Yeah.
Well, that's correct, but it needs to be rationalized. That's equal to root 3 over 3. Same number. And its sign is positive because it's third quadrant. So there's the exact answer.
Okay.
That's all we're going to do with any trig function. So with just what you see, in other words, between these two triangles and these unit circle quadrants, you can get the trig function of any angle. How about the sine of 390?
So, it would be 180 minus 390.
You always want to subtract multiples of 360 out of this.
So then 390 minus 360.
Yeah, so that's the same, exactly the same as the sine of 30, which is 1/2. It's in the first quadrant, so it's positive.
The sine value is the x, right, and cosine's y? Or is it the other way around?
The sine is the opposite over the hypotenuse.
I mean like x and y value. Is sine the x value?
Okay, let's draw a reference triangle here. This is the x value, this is the y value, this is theta, and this is 1. So I can say that the cosine of theta is x over 1. So x is the cosine. The sine of theta is going to be y over 1.
Yeah, alright, so the cosine is x, and then
Yes.
the sine up there.
Yes, in the unit circle, that's true.
Alright, this one, the cotangent of negative pi over 3. So,
Okay.
that would,
Well, first of all, let's talk about negative angles. Okay? Because there's a couple things you can do here. A negative angle means that instead of going counterclockwise, we're going to go clockwise, which means 60 degrees. So we're looking at a negative angle. There's the negative angle of minus 60 degrees, pi over 3. Okay? So we can do a couple things at this point. First of all, there's some very valuable things to know. Let me write them out. The sine of minus x equals minus the sine of x. Same with the tangent. And of course the reciprocals follow the same thing. So cotangent follows this. But the one that's not the same is this one. So if you're asked what's the cosine of minus 30 degrees, it's the same as the cosine of plus 30 degrees. If you're asked what the sine of minus 30 degrees is, it's minus the sine of 30 degrees. So you can basically take all these negative angle questions and turn them into this side. In other words, turn them into positive angle questions. Okay, so what was the question?
Cotangent of negative pi over 3.
Negative pi over 3. So that's equal to what, based on the second equation here?
The cotangent is equal to the negative cotangent of pi over 3.
Yeah, now all we have to do is work with this. Okay, so that's a first quadrant angle. What's the cotangent of 60 degrees if we look at this triangle right here?
Ooh, alright. Cotan, maybe 3 over 1.
That'd be tan. Remember, it's 60.
No.
60 is opposite over adjacent.
Oh.
So it's reciprocal, 1 over root 3, which again rationalizes to root 3 over 3. And the negative sign is right there. So there's our answer. I think much easier dealing with negative angles this way rather than trying to do them as a fourth quadrant angle. Notice that if I try to solve this as minus 60 degrees, well, that's the same as plus 300. But then to figure out plus 300, I subtract 360 minus 300, so I get back to 60 degrees in the first, and then I assign the negative sign because it's in the fourth. But the whole process is easier if you do this first step, convert it to positive angles. Now, this is that's still a fourth quadrant angle, notice. Minus pi over 3 is a fourth quadrant. If you get asked the question, what quadrant is this in? It's fourth. And that's why our final sign is negative, because we know cotangent is negative in the fourth quadrant.
Alright, so
those three, notice this fits the definition of odd. That's an odd function. This is an odd function, and this is an even function. So all of them are odd except cosine and secant are both even functions. All right.
So let's try cosecant of negative pi over 3.
Okay.
So it would be
now,
cos.
first of all, these are the quadrangles. Okay, so go ahead and convert it. In other words, remove the minus sign.
So it would be negative cosecant of pi over 2.
Right. Cosecant is the reciprocal of what?
Of sine.
Okay. So, if we look at the sine curve, pi over 2 is right there. So what is the sine of pi over 2?
It's 0.
1.
Or 1. Yeah, 1.
In other words, sine goes between 1 and minus 1. And it always goes for a period of 2 pi, which means this thing breaks up into perfect quadrants of pi over 2, pi, 3 pi over 2. So the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is minus 1, and so forth. So if the sine of pi over 2 is 1, the cosecant sits right on top of it. like that. That's the cosecant curve. What's the cosecant of pi over 2?
1.
Okay, so what is the answer to this question?
It's -1.
Right. Okay, so for your quadrangles, because these two triangles that I've drawn up here, they don't really work for the quadrangles being 90, 180, and 270. So in order to know what they are, you really need to have this curve memorized. These two, let me give you both of them. Cosine and the sine curve. You can do nothing better for your trig knowledge than to memorize these. And when I say memorize them, I mean all 4 points. By 4 points, I mean break that up into quarters. Because they go through their key points through these 4 quarters. Cosine starts at 1. In other words, the cosine of 0 is 1. As the next key point where it crosses the x-axis is going to be pi over 2. Then when it goes down to its lowest point, -1 at pi, back through the x-axis at 3 pi over 2, back to 1 at 2 pi. So what's the cosine of 3 pi over 2?
Okay, cosine 3 pi over 2. Pi over 2 would be 0.
Right. What is the sine of 3 pi over 2?
1.
No.
0.
-1. Follow the chart. Follow the graph. In other words, when I want the sine of 3 pi over 2, there's 3 pi over 2, its sine is -1. Okay? So with these two curves, you can answer all your quadrangles. And the only third curve you need to memorize would be the tangent curve, which has a couple of vertical asymptotes, and it goes like this. Okay, so what's the tangent of 0? Look at this curve. What point does that go through?
What curve are we looking at? I can't find you now.
The top curve, can you see that?
Okay. 0.
It's 0. Notice that the vertical asymptotes for tangent go from -pi over 2 to +pi over 2. So what is the tangent of pi over 2?
Tangent of pi over 2.
Yeah, looking at this chart, knowing these are vertical asymptotes.
Trying to think, like I just don't get it.
It's infinity.
The tangent of pi over 2 is infinity.
In other words, let me draw a bigger curve here so you can see it. We have vertical asymptotes, meaning that it's infinity at both of these places. Well, it's at negative infinity at one of them. It's at positive infinity at the other one. But tangent goes like this. And it always approaches those asymptotes. Now, let me explain why that is the case. Let's take this triangle. Okay? The tangent of 60 degrees is y over x, right? What's the tangent of 89 degrees? Notice that this triangle has all of a sudden become this kind of a triangle. This is still the right angle, but this is 89 degrees. It's still y over x, but notice what's happening to x.
Getting smaller.
Getting smaller. So as I approach 90 degrees, x goes to 0, and I end up with y over 0, which is infinity. So that's why the tangent of 90 degrees is infinite. It's kind of like the slope of a vertical line.
Okay.
Okay? So, but the best way to memorize your quadrangles is these three curves: the sine curve, the cosine curve, and the tangent curve. You can figure out the graphs of the other three based on the fact that they're reciprocals. But everything that you see on this page right now, let me erase this, will answer every question they ask you about the value of a trig function, no matter what it is, and no matter whether it's in radians or degrees. And, well, I'm sorry, as long as it's a multiple of 30, 45, or 60. Once you start taking trig functions of, say, 32 degrees, you have to use a calculator or a table. We have no way of figuring that out. Nobody knows how to take the sine of 32 degrees. You look it up. The sine of the common angles, like 30, 45, and 60, use these two special triangles to figure out those. And most of the first couple weeks of trig, they focus on your 30, 45, and 60 degree angles, and 90 and 180 and those kinds. So, all right. So you think you know how to figure out the trig function of any number? You want me to quiz you? You got some more problems, or?
Just quiz me real quick for a couple.
All right, let me make some up. What is the cosine of 120?
So cosine of 60 is pi over 3.
Hold on, let me give you the triangle. Cosine of 60 is what?
Pi over 3.
No. Remember, the trig functions are always a ratio of a number over another number. Pi only comes into it when it's in radians.
Yeah, but I mean, doesn't the cosine of 60 is pi over 3, right?
Yes, sorry.
And then
okay, I got it.
And then it's
So you prefer to convert it to radians. All right. So you got everything memorized in radians.
Yeah, that's how I figure out the coordinates. But I only know it for those three: pi over 3, pi over 4, and pi over 6.
Let me change this to 2 pi over 3 then, instead of 120 degrees.
So cosine of 2 pi over 3 equals pi over 3, which equals root 3 over 2.
No?
1/2. Oh, yeah, 1.
Okay. So it's equal to 1/2, and what is its sign? I always do these in 2 steps. I get the number first, and then the sign afterwards, because the sign is easy to get just from all students take calculus.
I think it's negative.
Correct, because it's second quadrant. In the second quadrant, only the sine and the cosecant are positive. Everything else is negative. Okay. Give you another one. What is the cosine of 7 pi over 4?
Would be root 2 over 2.
Yeah, that's good. What's the sign on it?
Positive.
Right. I'm going to erase those since you prefer doing everything in radians.
You can give me 1 in degrees. I'll try it.
All right. I'm impressed that you prefer radians, because most people will do anything to avoid radians, and they'll convert everything to degrees. But that you've memorized it in radians is good.
Yeah, we had to for trig. We had to keep taking this mastery quiz till we aced the whole circle.
Okay.
So 180, 225 minus 180. So cosine of 45.
Huh?
45. So adjacent over hypotenuse, 1 over root 2, you rationalize it. Root 2 over 2?
Uh-huh. And the
And then
sine?
it's 225 would be in the third quadrant, so it'd be negative?
Correct.
No.
Correct?
Yeah. Negative.
Yeah, that's exactly the way to do it. That's the process you want to use every time. You won't miss any. Let me give you a few quadrangles. What is the cosine of minus pi over 2?
So cosine of pi over 2, 1.
Look at the cosine chart.
Pi over 2. 0.
Right. These are huge. Make sure if you memorize anything on this page, you know these two. Because you're going to have to know these even better from here forward. In other words,
Actually, I need to remember that cosine is x, because it's like the cosine of pi over 2, that coordinate is 0, 1, which means that the cosine is the 0.
right. The x is the angle. The horizontal axis is the angle. This is the cosine x, the vertical.
Mm-hmm.
Same thing with the sine. So, what is the sine of 9 pi over 2?
So sine of pi over 2 equals 1.
Good.
I feel like I know these.
Okay. Let's go on then.
So the terminal point determined by a real number is given. Find the sine of t, cosine of t, and tangent of t.
Okay.
The coordinate is 3/5, 4/5.
So here, let me erase this tangent curve. So they're saying that's 3/5, 4/5.
Yeah, that's the terminal point.
That's the terminal point, and they want this angle, right?
Yeah, they want sine, cosine, and tangent.
Okay. So if that coordinate point, remember that the well, what's the easy way to do this?
Yeah, I was thinking. Yeah.
It's a 3, 4, 5 triangle. The 4 is clearly here because for the x coordinate to be 3/5, the 3 has to go with the x, the 4 has to go with the y.
All right, and then you just SOHCAHTOA it.
You know what? Let's do this a different way. I don't like the way I did that. Here, let's do this a different way. We know that this is 3/5. We know that this is 4/5. Let's use the Pythagorean theorem. Well, first of all, that tells us the tangent instantly. So what is the tangent of theta?
4/5 over 3/5.
4/3.
Times. Yeah.
Okay. In order to get the sine and the cosine of theta, I guess we need to solve the Pythagorean theorem for this number.
So 3/5 squared plus 4/5 squared.
Yeah. 3/5 squared plus 4/5 squared. When you do that math, you're going to get 5/5.
So I got, yeah, 1.
So this is 5/5, the hypotenuse. I solved for it exactly. Okay? Now that you have the dimensions of all three sides, you can give any trig function you want. So sine of theta is what?
4/5 over 5/5.
Which is 4/5, and cosine of theta?
15 over 25.
Okay. So that's the way we're going to do all of these. We're going to set up, solve for the hypotenuse, no matter what coordinates they give us, and then we'll have all three dimensions of that right triangle, and we can tell you all 6 trig functions. So what's the next one?
So it's root 5 over 5, comma 2 root 5 over 5.
Like that?
Yeah, and then over 5 for the 2 root 5. Yeah.
Okay. So root 5 over 5 is the x-coordinate. And the y dimension is 2 root 5 over 5. So this is 2 root 5 over 5. We're trying to solve for that hypotenuse. What is it? Again, we could get the tangent instantly. We don't need to solve the hypotenuse for the tangent. But
so I'm confused right here. How would you multiply that, distribute that 2 to the 2 root 5?
okay, let's square the first one. First one squares 5 over 25.
5 over 25.
Plus,
So 1/5.
we square the 2 and the root 5, so this becomes 4 times 5 over 25. So that's 1/5 plus 4/5 is 5/5. So 1 is the answer for the hypotenuse. Notice that both the last problem and this problem, 1 was the hypotenuse. So we might safely assume the hypotenuse is always going to be 1, and we can just do our trig functions immediately. Unless we see otherwise, that it looks like it's not going to be. So what is the sine of theta?
2 root 5 over 5 times 5 over root 5.
No, the sine of theta is opposite over hypotenuse, so it's just this over 1, or just that.
Oh yeah, over hypotenuse. So 2
Cosine of
then the
theta?
cosine would just be root 5 over 5.
And the tangent?
2 root 5 over 5 times 5 over root 5.
Well, it would be opposite 2 root 5 over 5 divided by root 5 over 5. Notice that if I flip this and multiply, these go away and those go away, so it's equal to 2.
Alright. That makes sense. So,
do one more of those? Let's
no,
do one more and have...
you.
All right. That's fine. There is kind of a classic question that you're going to get asked, so let me give you some problems. Sine of theta equals 2/7, and theta is in the first quadrant. Give me the other 6 trig functions.
Okay, so you draw your thing, theta.
I only draw a triangle. I do not draw the unit circle here.
Yeah, that's what I was doing.
And I think it makes sense. So even if this is not in the first quadrant, I don't draw the unit circle. In other words, I'll show you why. This is a real easy problem if you do it this way. So when they give you one trig function, draw a triangle, label theta. It's very important to do both of those. Label theta. Now, how can I dimension that triangle? How can I start dimensioning it?
Play the 2/7 on the bottom.
Right there. If the sine of theta is 2/7,
that makes
that's
sense.
2, that's 7. Now, this is the square root of 49 minus 4, so this would be the square root of 45. In other words, the one trig function allows you to put two sides on the triangle. The Pythagorean theorem allows you to put the other. So that's 3 root 5. Now, it's a piece of cake to come up with all 6 trig functions. What's cosine of theta?
3 root 5 over 7.
Okay, so you can, what's the secant of theta?
7 over 3 root 5.
Yeah, and then you'd need to rationalize that. But, okay.
How do you rationalize it?
By multiplying it by root 5 over root 5.
So that would be 7 root 5 over 3.
7 root 5 over 3 times 5, over 15. So there it is rationalized. Okay? But this process, now, it's not going to matter. Let's say, same exact problem, only this time it's second quadrant.
So you just change the signs of what you...
Exactly, based on all students take calculus. So tell me what the tangent of theta is.
It would be...
What was this again? This was 3 root 5?
Yeah. 3 root 5 over 15, I think.
Well, it would be opposite.
No, I mean 3 root 5, wasn't it over 15 too?
No, it was just 3 root 5. Because remember, this
Then
is the square root of 45.
It would just be negative 2 over 3 root 5.
Right. Negative 2 over 3 root 5, which rationalizes to negative 2 root 5 over 15. Would you always rationalize a denominator by multiplying by that thing? Only you can only multiply a fraction by 1 without changing its value. So if I have 1 over root 7, I got to multiply that by root 7 over root 7 to rationalize it.
I'm pretty sure you're actually going over what I was just going to ask you. It says find the values of the trigonomic functions of t from the given.
Right. That's
Sine of 3 fifths.
That's a very common problem. The difference is that a lot of the solutions will try to solve it based on the reference angle and which quadrant and the unit circle. And I think that's a waste of time. Let's dimension a triangle. Doesn't matter whether it's the right reference triangle or not. And there's not going to be any problem assigning a plus or minus sign to whatever value we come up with. That's the easy part of trig, as long as you know the quadrant you're in.
Okay, so let's try, this one says secant of t equals 2, and the sine of t is less than 0.
Okay, so if the secant of t, here's my triangle, here's t.
So that would be the cosine of 1/2.
So if the secant of t is 2, that's the hypotenuse over the adjacent.
Yeah.
So what's this side over here?
So it would be 4 minus 1, so 3.
Root 3.
Root 3.
Remember, it's the square root of 4 minus 1. So there's our triangle. Now, they're kind of telling us what quadrant it is in by telling us that secant is positive and sine is negative. Which
so
quadrant?
it's in the third or fourth.
No, it's more specific than that. If secant is positive and sine is negative, sine's negative there and there, but secant's only positive there. Secant is negative in the third. So, this information they've given us tells us that it's fourth quadrant. Same thing as fourth quadrant. T is in fourth quadrant. They might as well have said that. They just make it a little harder to figure out. So, and what are they asking for?
Just the same thing, find all the...
Okay, so what's the sine of T?
Root 3 over 2.
Plus or minus?
Minus.
What's the cosine of T?
1 over 2. Be positive.
Correct.
Roots in the fourth. Yeah.
Correct. So that's all you do, is you come up with the number based on the triangle, you come up with the sine based on which quadrant it's in. And this is about as tricky as they get, where they don't tell you the quadrant, they just tell you that another function is plus or minus and forces you to figure out the quadrant.
Yeah, this next one says, determine whether the function is even, odd, or neither.
Okay?
First one is x squared sine x.
Remember how we figure out whether a function is odd, even, or neither? Odds means f of minus x has to equal minus f of x. Even means f of minus x equals f of x. So let's figure out what, in other words, the first thing you do to decide whether a function is even or odd is you plug in minus x instead of x. So when I do that here, what do I get? So what is f of minus x for our function?
I think it'll be odd then, because negative x squared is positive, but then the other x will be negative.
Correct. In other words, and then we have sine of minus x, which is the same as minus x squared sine of x, which is equal to minus f of x. So that is odd.
Alright, so the absolute value of x cosine x. So I would guess the x in front is the only thing in the absolute value.
What's an absolute value function? Is that odd or even?
I think in this case it would be odd.
Even.
The absolute value is only on the first x.
Well, just a second. First of all, the other definition for odd and even is an even function is symmetrical about the y-axis. An odd function is symmetrical about the origin. Here's the absolute value function. That is symmetrical about the y-axis. That is even. Notice that the cosine function we knew was even, but look at it, why it is even. It's even because it's totally symmetrical about the y-axis. And the sine function, which we know is odd because it's totally symmetrical about the origin. By that I mean if you flip it relative to the x and the y, you'll find symmetry. So first of all, we know sine is odd and cosine is even, but this relationship between symmetrical, in other words, my first instinct here is to say this is even based strictly on the fact that it's absolute value. Notice what the absolute value of the sine function looks like. Is that even or odd? Oops, excuse me. I didn't do that right. That's not what it looks like. What it looks like is this. So that's neither. The absolute value of the sine function is neither. Okay, so
Alright, I have to get going now. Say class.
okay. You were right on this. This is going to be even because cosine of minus x is minus the cosine of x, so this is the same thing as x cosine x.
But the absolute value is only on that first x. That makes a difference, right?
Actually, it doesn't. That means this one's even, and this one's always even, so it's still even.
Oh, okay. Makes sense.
Okay. I will talk to you at 10 on Wednesday. Michael?
Yep. We're going to do true. That's when we get into graphing on Wednesday.
Great. Great. Okay.
Thanks a lot.
Bye-bye.